Have you ever wondered how we can look at a bunch of numbers and somehow predict the future? Or make sense of the past? Well, today we're going to break down the two fundamental types of statistics that make all of that possible. This is like the core skill for anyone who wants to turn raw data into smart decisions. Seriously, how do they do it? How does a weather app have any idea if it's going to rain tomorrow? Or how does it feel like an online store is reading your mind? Well, the answer to all of that is statistics. And it's woven into our lives way more than you probably think.
I mean, just think about it for a second. That classic ad line, 4 out of 5 dentists recommend? Yep, that's statistics. Or that wild fact that if you get 30 people in a room, there's a 40% chance 2 of them share a birthday? That's statistics too. From your test scores to company sales reports to huge public health findings, these aren't just random numbers. They are the language that data speaks.
Okay, so if it's literally everywhere, what actually is statistics? Let's get a really clear, simple definition.
At its heart, statistics is really a 4-step process. You collect some data, you analyze it, you interpret what it's trying to tell you, and then you draw some conclusions from it. It's basically the engine that takes a whole mess of raw numbers and turns them into clean insights that help us make much, much smarter choices.
You know, a great way to think about it is this. Statistics is all about finding the story that's hiding inside the data. And to find that story, every analyst uses 2 fundamental approaches. Let's dig into the first one.
All right, so our first type is called descriptive statistics. And this is always where any good data analysis begins. It's step 1.
So the main goal here, the whole point really, is to just organize and summarize the key features of the data you already have. It's not about making wild guesses about the future. It's about getting a crystal clear picture of what's already happened.
And how do we do that? Well, with some pretty straightforward tools, actually. We use things like graphs and tables to literally see the data, and we calculate some simple numbers you're probably already familiar with, like the average, the mean, median, and mode, and other things like variation and percentiles. It's all about describing what the data is showing us right here and now.
I love this analogy. Think of descriptive statistics like a class photo. It perfectly captures that specific group of kids at one single moment in time. You can see who was there, how tall they were, what they were wearing, but it tells you absolutely nothing about what they're going to do next year.
But what if you do want to predict what might happen next year? What if you want to go beyond just describing what you can see? Well, that is where our second and really powerful type of statistics comes into play, inferential statistics.
Okay, so here, the game completely changes. The goal is to take a small, manageable chunk of data, we call that a sample, and use it to make an educated guess or an inference about a much, much larger group, which we call the population.
Let's use a super practical example. Imagine you want to know the average height of all 100 students in a school. Measuring every single one would be a pain, right? So instead, you take a small representative sample of, let's say, 10 students. You find their average height, then, and this is the magic part, you infer that their average height is probably really close to the average for all 100 kids. You're using what you know to make a really good guess about what you don't.
But hold on, an educated guess is still a guess, isn't it? How do we deal with that uncertainty? This is where inferential statistics gets really cool. It gives us tools like a confidence interval to say exactly how sure we are. We can actually make a statement like, we are 95% confident that the true average height for all the students is somewhere in this range. That is incredibly powerful stuff.
Okay, so we've got these 2 big ideas, descriptive and inferential. How do they actually work together in the real world? Well, it all boils down to a simple but absolutely critical 2-step process for any data analyst.
This table just lays it all out perfectly. Look at the goal. Descriptive is about summarizing what you have, while inferential is about predicting what you don't. And the scope? Descriptive is just about the data right in front of you. Inferential is about that bigger group you haven't even measured. The example says it all. Finding the average score for this class, that's descriptive. Using that to estimate the average score for all students in the whole country, that's pure inferential statistics.
So, if you remember one thing, remember this workflow. It's always a 2-step dance. You always start by describing your data. You organize it, you summarize it, you get a feel for what happened. And only then, once you have that clear picture, can you move on to the next step and start inferring what it all might mean for the bigger picture. Describe, then infer.
And there you have it.
That's the fundamental framework. It's how data scientists turn a spreadsheet full of numbers into a compelling story. You start by describing the characters and the setting, and then you infer the plot. So now that you know the process, the only question left is, what story is your data just waiting to tell?